Beneath the Martian dust lies a place older than the crater it lives in. A place forged in the chaos of Mars's infancy. And now Perseverance has arrived. In May 2025, NASA's most advanced rover reached a rugged alien plateau named Krokodillen, a name borrowed from a Norwegian mountain ridge, meaning crocodile. But this stretch of rock is more than just another waypoint. It may hold clues to a time so distant, so primal, that Earth itself had barely formed continents. And if those clues include signs of life, they won't just rewrite what we know about Mars. They might rewrite what we know about life in the universe. Chapter 1. The Journey to Jezero. Perseverance touched down in Jezero Crater on February 18, 2021, after a high-stakes descent nicknamed the 7 Minutes of Terror. Its descent was a historic leap in precision landing, made possible by autonomous hazard avoidance software and a sky crane system that gently lowered the car-sized rover onto the Martian surface. Jezero wasn't picked at random. Satellite data showed an ancient river once spilled into the crater, creating a sprawling delta rich in clay sediments, deposits that, on Earth, are famous for preserving traces of microbial life. In essence, Jezero is a natural fossil trap, and the mission was designed to explore it with surgical precision. Since landing, Perseverance has been a rolling laboratory. It's driven more than 17 kilometers, capturing panoramic images, scraping rocks, vaporizing minerals with lasers, and analyzing their composition down to the micron. It's even recorded sound on another planet for the first time. The rover has investigated key locations like Saita and Mars, regions with both igneous and sedimentary rocks. These allow scientists to reconstruct the planet's environmental history. In 2024, the discovery of potential biosignatures at Jezero Falls raised eyebrows. Chemical gradients and fine layering patterns hinted at ancient microbial life. It was a moment that reignited global excitement, but also highlighted the limitations of onboard instruments. And now, Perseverance is doing something unprecedented. It's entered terrain that predates the crater itself. Chapter 2. Krokodillen, Mars. Before the crater, the Krokodillen Plateau, a 73-acre geological shoulder between crater rim and volcanic plain, is now the rover's newest and possibly most significant target. This is where time folds back on itself. The rock here belongs to Mars' Noachian period, dating over 4 billion years ago. This era is known for violent volcanic activity, torrential flooding, and possibly oceans that once blanketed parts of the planet. While Earth was just beginning to stabilize into continents and oceans, Mars may have already had habitable conditions. Unlike Earth, which erases much of its ancient history through plate tectonics and erosion, Mars has no such tectonic recycling. That means rocks this old, untouched and pristine, still sit exposed at the surface. These rocks likely witnessed the birth of the planet's first rivers, the loss of its magnetic field, and the slow thinning of its atmosphere. Their mineral composition, especially the presence of phyllosilicates like smectite and kaolinite, indicates prolonged interaction with water, possibly neutral to slightly alkaline water, which is ideal for early microbial life. To scientists, Krokodillen is not just rock. It's a record of time before Jezero filled with water, before impact reshaped its rim, before any crater existed at all, and Perseverance is the first to reach it. Chapter 3. Biosignatures and the Burden of Proof. Biosignatures are among the most difficult things to detect in planetary science. On Mars, where no confirmed life has ever been found, the burden of proof is immense. A biosignature could be anything from complex organic molecules to microscopic textures that resemble microbial mats. But here's the problem. Mars mimics life frighteningly well. Geological processes can produce structures that look biological. Non-living chemistry can generate organics. Even something as compelling as layered carbonate deposits, strong signs of biology on Earth, can form abiotically on Mars. At Cheyava Falls, Perseverance observed finely laminated rock structures, chemically altered in ways that suggest water flowed repeatedly and potentially nourished life. But those features remain ambiguous. Without isotope ratios or high-resolution mass spectrometry, both impossible with the rover's current tools, the science team must wait. That's where the mission's second goal comes in: sample caching. Perseverance doesn't just observe Mars, it collects it. It drills cylindrical cores and seals them in titanium tubes for a future mission to return to Earth, where labs can analyze them with thousand-fold more precision. But time and bureaucracy are working against that plan. Chapter 4. The Sample Struggle. The rover was given 43 tubes, 38 for actual Martian samples, and 5 witness tubes to test for Earthborne contamination. As of May 2025, only 7 sampling tubes remain unfilled. Facing this scarcity, the science team, led by experts like Katie Stack-Morgan, has adjusted tactics. Some new samples are left unsealed, allowing the team to discard them later if better targets arise. It's an agile, calculated risk, one that maximizes scientific return in uncertain circumstances, and uncertainty is growing. The Mars Sample Return (MSR) campaign, originally a joint venture between NASA and the European Space Agency, is under threat. The Trump administration's 2026 budget proposal calls for cancelling it due to cost overruns and timeline delays. It would leave every tube Perseverance has filled, possibly containing ancient Martian biosignatures, stranded on another planet. Years of planning, billions in funding, and the most advanced geology robot ever built, all potentially for nothing, unless something changes. Chapter 5. Why this plateau matters. The deeper significance of Krokodillen is not just scientific, it's philosophical. This is the oldest terrain Perseverance will ever explore. These rocks were formed during Mars' infancy, possibly when it had a global magnetic field, a dense atmosphere, and liquid water on the surface. Life, if it emerged, would have needed shelter, perhaps in subsurface clay pores or beneath protective mineral layers. And clay is exactly what's being found here. Even a negative result at Krokodillen, no biosignatures, no organics, would be monumental. It would help constrain when and where Mars might have been habitable and explain why Earth succeeded where Mars may have failed. Alternatively, a single compelling biosignature, fossilized or chemical, could prove we are not alone in the cosmic biological experiment, that life doesn't require Earth's exact recipe, that it may have sparked more than once, in more than one place. Mars, in that case, becomes not a dead world, but a sibling that once thrived. Chapter 6. The broader context. Beyond Perseverance, Mars is evolving as a canvas of mystery and revelation. In 2025, data from the ExoMars Trace Gas Orbiter added new support to the idea of subsurface methane, a possible byproduct of biology or deep hydrothermal reactions. The InSight lander, before its shutdown, delivered invaluable seismic data, revealing a partially molten core and surprising internal layering, suggesting a more dynamic Mars than previously believed. And in the upper atmosphere, faint auroras captured by MAVEN and Perseverance hinted at the continued interaction of solar wind with crustal magnetic remnants. Add to that strange surface features, dark streaks, polygonal fractures, odd reflective patches, many of which remain unexplained. Every new image, every new reading reminds us that Mars is still writing its story, and Perseverance is one of its few remaining narrators. Ending hook. Now, as it roves across Krokodillen's jagged ridge, Perseverance drills not just into stone, but into the forgotten history of a world that may once have breathed. Each sample could be a page from a lost chapter of planetary evolution. But whether we ever get to read that chapter depends on what we do next. Subscribe and stay tuned, because the final truth about Mars may already be in Perseverance's hands. The question is, will we bring it home?